first RAG pipeline in Python with Azure OpenAI Azure Foundry. Before going into the topic, just wanted to give the quick introduction. This is Balaji Venkata Subramanian. I have a 13 plus years of work experience in enterprise software development, technical lead, and technical architect. My end client is FANG-based company. I'm currently working for one of the top insurance TPA. Further delay, let's jump into the topic. What is LLM? LLM is a large language models. It's an AI system and trained on massive amount of text data. It capable of understanding human generated language. So let's talk about that. 2022, OpenAI launched the GPT thing 3. So it was a massive hit. People are crazy about it. They went and they asked the question, it gives the proper appropriate answers. So it was very, very big uh, changeover. Previously, we ask a question in the Google, it gives the 10 web pages, top 10 pages, and then we go and find the answer. This is one of the best thing because they trained billions of data. And then later on, Google launched the Gemini, Anthropic launched Claude, and then Meta launched Llama. So every other model have their own strength and then weaknesses. ChatGPT is a general model, general frontier model. So Google Gemini is very good at image generation, nano banana, and Claude is very good at generating the code for doing the development, fixing the bugs. Everything works fine. Llama is a open source model. This is what it is. Now, what's the problem? LLMs are powerful but incomplete. Why it's incomplete? You can ask me. I'll tell you the problem with the LLM. So as soon as the all the LLMs were launched, it is good, but how do you make it? How companies can earn money from that? So they have to blend the LLM to make to work in your company task, or you have to provide some kind of service which makes people to get the problem solved easier. Then only you can able to generate a money out of it. So how we can make it? So these are all the problems. And LLMs are great, answer the general knowledge questions, but no access to your company data. Let's say you can ask your company how many employees, I mean, you can go and ask to ChatGPT or Claude, how many employees are working in my company, how many of them were software engineer, how many of them are QA. It won't be able to answer because it doesn't know the information, right? So that's what I'm saying. No access to your company data. Summarize, translate, write content. It does very well, but knowledge cutoff not real time. Most of the models are not real time. If you ask a question about the current today's weather or some of the today's news, it won't tell because it's not trained that way. And explain the complex topic simply, which is good, but hallucinate confidently, which is we don't want that. And code generation and debug, which is doing fantastically good job and no memory of your document. Creative brainstorming cannot query the internal database. Yes, there are some frameworks came in, but we are going to discuss one by one. So making LLM works for your organization, that's the ultimate goal. So how are you going to do that? So later, GPT came 2022, 2023. What happened was like most of the companies went and started training the LLM. Means with their company data, proprietary data, they started training it, but put a cap on that, not to go with the outside of the company. LLM should not train the information that shouldn't go out of the company layer, but inside they started training it to make use of their own problem. But what happened? You know, after 6 months, the chat GPT launched GPT 4. It was massive, very efficient, wonderful LLM. It's a very, very powerful model. But see what happened? Companies wants to retrain the LLM again. So they have to spend a lot of money buying the GPU and retraining the data gathering. You know what? It's waste of time, waste of money. So that's where the topic RAG came into the picture. It's a retrieval augment generation. What's the RAG means? So you don't need to retrain the LLM. Instead, you can create a smaller brain inside your company using the vector database. In that vector database, you can store all of your company information by chunking it before hitting the LLM, before you ask the question or hit the LLM. Your question will go through the RAG pipeline in your vector database, find the relevant information, and go to the LLM and get back the answer. So, this way, though the LLM is outdated or it's becoming powerful, you just need to plug out and plug in. That's it. So your RAG brain is going to be still same. You train as much as you want. It will keep the information with your company. It's completely secured and you can scale it at any level and you can plug in and plug out whatever model is becoming powerful. This is the idea of RAG. I'll discuss more on next slide. This is the complete RAG architecture. So the same way I explained, let's say we are going to create a chatbot for your company. Think about it. So you created a UI. Now user is going to prompt it. What you have to do, you have to go and search your own internal company policies, reports, manuals. Forget about the database for now, and wikis. Forget about the API also. So it needs to grab the information from that. Basically, it's going to filter some of the data. Consider you have 100 page of document. The question you ask, it's in the 10th page of your document, and then it's going to bring only the 10th page of document and then goes to the LLM. And based on your question and your context, it will prepare the answer. LLM is going to prepare the answer, and then it's going to give back to your UI. That's the pretty much RAG works. Okay, now let me give you a simple example how RAG works without any code. I hope everybody see my screen. So now I open a new chat. I'm attaching a file that is a leave policy. If you can look at this policy data. So this is what it is, my company policy. How I'm going to ask how many leaves I will get every year. So the way it works is like it just put the content. How many leaves I will get every year. If you look at that, first year 15 days, second year 15 days, per year 20 days, beyond 6 years based on my company policies. So this is what the information it get. Without the data, it won't give the information. Right? This is a RAG. This is a without programming, it's a simple RAG. Hope you all understand what's meant by RAG. Now, let's go back to the topic. So now there are different types of RAG architecture, I would say. Nav RAG, which is basic RAG, I call it as, and then advanced RAG, and then modular RAG, agentic RAG, which is my favorite topic. So the basic RAG is like whatever I suggested now. You have to chunk your company policies, your data, and then store it into vector database. As soon as you ask a question, it's going to search, do the semantic search in the vector database, pull the information, and pass it into the LLM, bring back the answer. That's one type. An advanced LLM. Look what I said. We are going, I mean, in your basic LLM, you're going to hit only once. But advanced LLM, advanced RAG concept, you'll be hitting two times LLM. First, as soon as user asks the question, you're going to hit the LLM to regenerate the question to make it more appropriate, and then do the semantic search, get the answer, right? And then again call the LLM to with the proper big, I mean, the very explained answer with the with answer and with questions. So you will get a more appropriate answer, more good response. And then I hope I explained well. So if you are not clear about it, please feel free to comment. I'll reply on that. Then modular rack. Modular rack is mixed drivers, basically. What it does is like, so it get the answer from the LLM and then get the answer from the vector database, combines it, again it push to the LLM, it get the better answers. So that's how it works. Then agentic RAG, as I said, it's one of the best ragging architecture. If you guys worked on the cursor or Cloud Code, everything works on the agent RAG. How does it work? As soon as you ask a question, let's say, can you build a small, probably billing software? Let's take an example. So as soon as you ask a question, it's going to split the task into probably 5 or 6 different tasks. One is to create a UI, another one is to create a build a backend, another task is to test the UI, another task is to test the backend, another task, fifth task is to test the integration, sixth task is to make sure the design is well, something like that, and seventh task is going to make sure everything works fine, end-to-end testing. So what is going to happen is like all 6 to 7 tasks, it's going to create a 6 to 7 sub agents on top of that one agent. So basically 8 agent. So each and every sub agent work independently and then get the output back, finally consolidated. It'll go to the all the 8 sub agent response to the parent agent. So that parent agent will consolidate it. It will check is all the sub agent return the appropriate response. If not, it's going to loop again, retry it as soon as, I mean, it just do the loop again and again, make sure to get a response back, the successful response in all the sub agent. Once it moves out the result. That's how the cursor is working and Cloud Code is working. See, you're saying you understand what I'm saying. I probably can take a best topic later at some point about the agentic RAG. RAG optimization technique. So we developed the basic RAG, but like as soon as you ask a question, it's responding. But you wanted to optimize it well. So based on the user question, you will be understanding it. Initially, you just deployed it, which is good. And then later on, you will understand the user persona to making sure how the users are asking. You wanted to make you wanted to give your AI to give the better response each and every time. So that's what the query transformation does. Rewrite it, expand it, before search, improve the quality match, all the things you have to do. That hybrid search, combine the LLM data, again vector similarity search, best both of the both version, and then it's going to reply it. Re-ranking it may ask to probably the LLM is going to give the two kind of response, has to give the two responses, and then whatever the best matches is going to give it. Optimization, smart chunking, semantic, recursive, much more it's there. It's basically you are going to optimize after it went to live. First version, second version is going to be a better and better. LLMs are going to be a better and better. That's what it's going to be, optimization technique. Next one is evaluating RAG system, one of the important topic. How are you going to test your RAG system? There are 4 types of RAG testing system: faithfulness, context recall, answer relevance, and then evaluation frameworks. Faithfulness, make sure your answer is grounded. Basically, it picks up the right content or not. Or maybe some people ask for give the more information. So it has to pick up the right content. So if you are going to chunk it of 500 letters of word, you may need to do the little bit, uh, uh, probably a little bit lesser chunk so that it understand more, or maybe you have to increase the chunk based on your data. Recall the context. So what does that mean? So is it picking up the right context? Maybe if the answer is in the 10th page, but 5th page it is picking up, means you have to retrain it. You have to change the content. So that kind of level you have to do that. Answer relevance. See how is it answering very nicely? How it is based on the scoring, a lot of things were there. The evaluation frameworks are best. So there are other outside framework were there. So you can test your rack system, racks, TrueLens, multiple. So you can use it to test it. So now quickly we are going to show the demo. So this is a simple RAG project I have developed it. So when I said this is the ingest model, this is going to be one of the pipeline I'm going to set up it. This pipeline, what I'm going to do? Loading the document. So basically I have a three set of document. This document, I'm loading the document, right? So load the document and then I'm using the Cosmos or Chroma, any DB you can use it. Let's go for the Chroma DB. So I'm using the Chroma DB or Cosmos DB. So any DBs, right? So in that DB, what I'm going to do, I'm going to chunk the text first and embedding. I forgot to tell about one thing, embedding model. So I'm going to talk more detail in the vector database topic, but for now, embedding is another model which convert your text to an integer. That's what it is going to do. Currently, I'm using the OpenAI model, this embedding model. So this is my embedding model. Yeah, text embedding 3 small model. So that is one. Then what is going to do? Embedding models. So it just convert the text into the integer and then chunk it, store it into the vector database. That's what it is doing, pretty much it is doing. Whenever I ask a question, it's going to search again. My question is going to be change it into again, it's going to convert as embedding stuff, and then it's going to search into vector database, bring back and connect to the LLM. That's what it is going to do. So, so it's going to search the build the prompt first, and then here I'm connecting the LLM. Okay, that's one thing. So here I'm embedding the text again and getting the retry the question. It's going to embed it and then query it. Here I'm going to build the prompt and connecting the OpenAI. That's it. Let's look at the output. Now, this is the output. This is the question I'm going to ask in my app. Look, exact same answer. I got it. And then I would like to show you the step-by-step guidance. So set up ingest by a PY vector database. And whenever you ask a question from main.py or web.py, which I showed you, RAG pipeline ask, answer the source from this question. This is how it is going to be. And this is the pipeline wiki I'm going to show. This is going to be one of the pipeline. Your ingest.py is going to chunk the text and then using the embedding model to convert the text into the integer and storing into the vector database. And then from web, if you ask a question, it's going to do the similarity search from the vector database and then connect the Azure OpenAI and answer your question. That's all it is. So with that, I'm going to end the session. Thank you so much. We'll see next session.